Today we're going to start section 10.7, which is write and graph equations of circles. And for the whole chapter, this is the section that you will probably see come up over your next couple years in Algebra 2 and Pre-Calculus, where we're looking at circles on a coordinate plane. The equation of a circle comes from distance formula. If you remember, the definition of a circle earlier in the year was the set of all points in a plane that are a given distance, which is the radius, from a given point, the center. So here I have a circle on the coordinate plane where the center is at HK and the radius is R. Distance formula says distance equals the square root of the difference of the x coordinates squared plus the difference of the y coordinates squared. And remember, distance formula actually comes from Pythagorean theorem. But we're going to start here. The distance is equal to the difference of the x coordinates squared plus the difference of the y coordinates squared. When I have a circle, the distance is the radius. The x and y coordinates come from the point on the circle and the coordinates of the center. H and k will be a given number for a circle. X and y are all the x and y as we go around the circle. So I have the square root of x coordinate minus x coordinate squared plus y coordinate minus y coordinate squared. And it's easier if I put the unknown x and y first. So I have x minus h squared plus y minus k squared inside that square root. If I take this equation and I square both sides, it eliminates the square root, and I get r squared equals x minus h squared plus y minus k squared, where r is the radius of the circle, and hk are the coordinates of the circle, of the center of the circle. This is what is known as standard form of the equation of a circle, and it's a really useful form because the radius and the center are right in it. So standard form is usually written as x minus h squared plus y minus k squared equals r squared. Again, r is the radius and hk is the center. And today we're going to look at some ways that you can write the equation of a circle in standard form. One comment on the homework: if it tells you to sketch the equation of a circle, you do not need to draw it in great detail. Put the center at its location and count the radius to the left, right, up, and down, and then just do the best you can filling in the circle. So here we're going to write equations. I have a circle with center 4, -2, so that's my h and k, and my radius is 3. That's my r. If I have the center and radius, it's very easy to plug into standard form. X minus the x coordinate of the center squared plus y minus the y coordinate of the center squared. So this is y minus -2, so it's y plus 2 squared equals the radius squared. 3 squared is 9. And I'm done with that problem. And again, if you were going to sketch this circle, what you could do is put the center at 4, -2, and then with a radius of 3, I would just count 3 to the right, 3 to the left, 3 up, and 3 down, and then do the best you can to make this look something like a circle. It's not very good. Sometimes we're not given the center and the radius. In this problem, we want to write the equation of a circle that passes through the point -6 and has the center -6, 3. So we have our h and k, but we don't have our radius. Radius is the distance from the center to any point on the circle. So to find the radius, I'm going to find the distance from the center to the point that I know is on the circle. So I have the square root of, it doesn't matter which order I do this in, it can be -2 minus -6 squared plus 6 minus 3 squared. This is 4 squared plus 6 minus 3 is 3 squared, so it's square root of 25, which is 5. Now, since I know the radius and I know the center, I can plug into standard form. X minus the x coordinate in the center, so minus -6 becomes plus 6 squared, plus y minus 3 squared equals the radius squared. 5 squared is 25. You'll notice over here, we had r as the square root of 25, so r squared is 25. One more type of problem you'll be doing today where we want to write the equation of a circle where we're given the endpoints of a diameter. So this is a circle where we know 2 endpoints of a diameter. We don't know the center or the radius. We can find the center because the center is the midpoint of those endpoints of the diameter. If I have a circle with any diameter, the center is always in the middle of those 2 endpoints. So the center here, if you remember midpoint formula, you average the x's to get the x coordinate and you average the y's to get the y. 1 plus negative 3 over 2, average the x coordinates. 4 plus 2 over 2, average the y coordinates. So my center is negative 2 over 2, which is negative 1, and then 6 over 2 is 3. Here's my h and k. Once I have the center, I'm going to do what we did above and find the radius. The radius is the distance from the center to any point in the circle. So you can pick which of these endpoints of the diameter to use. For example, if I want to use this point and my center, radius, using distance formula, square root of 1 minus negative 1 squared plus 4 minus 3 squared. That's 2 squared plus 1 squared. 2 squared is 4, 1 squared is 1, 4 plus 1 is 5. My radius is square root of 5. So when I go to plug into my equation, x minus the x squared in the center, so minus negative 1, again becomes plus 1 squared, plus y minus 3 squared equals square root of 5 squared. When you take the square root of 5 and you square it, you get 5. And this is my equation in standard form. So for today's homework, you're going to use midpoint formula, you're going to use distance formula, and you're going to get comfortable with standard form of the equation of a circle. Tomorrow, we're going to use what you learned about completing the square, or reviewed about completing the square yesterday, and you're going to take different forms of an equation and turn it into the standard form. Please make sure that you understand the steps involved in completing the square.